In this video, we'll continue with the second episode of logarithm, and we'll be reviewing as many examples that will be given to us, and we'll be reviewing equations of logarithm and so on. So let's quickly dive into example 1. So in this example, we want to simplify the logarithm example. Now, logarithm questions usually have a high similarity between with indices. So we want to evaluate log 2 log x plus 3 log y minus 4 log z. Now you notice that we have an addition sign. Now whenever you see two logarithms adding themselves together, what you are going to do is you are going to use multiplication, that is log a plus log b is equals to log open bracket a times b. If you have log x plus log y, the answer for log x plus y will be log x, it will be log open bracket x multiply with y. But before we do that, let's simplify the logarithm by taking the coefficient of the log, which is 2, to the upper power of x. So we simplify, we take the power, the coefficient of 2, which is the coefficient of the log, which is 2, to the power of the x. So we have log x squared, similarly plus log y cubed minus log z raised to power 4. And by the law of logarithm, whenever you see addition simply means multiplication. So you factor out the log and you have x squared y cubed divided by z raised to power 4. Why do we have division? Division because of the subtraction symbol that we have there. So that is why we have divided by z raised to power 4. So let's quickly move to other examples. Now the second example is more like the inverse of the first example, because the question, the logarithm, is already simplified, or rather we say it is already in its condensed form. So we want to take it from the condensed form to the general form. Now we have log r squared x squared divided by z raised to power 6. So we want to take it from the condensed form to the simplified form. Now what we do is that since everything, all of the logarithm is conjoined together with both the multiplication and the division, we can separate them. So that's going to be log r squared plus log x raised to power 5. Now why do we have plus there? The reason why we have plus there is due to the r squared multiplying x raised to power 5, and the reason why we have the negative, the subtraction sign, is due to the division sign that we have, that's minus log z raised to power 6. Now by simplification, in the law of logarithm, we can take the power of r to the back of the logarithm. So we have 2 log r, similarly plus 5 log x minus 6 log 6. So this is the general form of the given condensed logarithm. So let's move to other examples. So we have 1 over 2 log x minus 1 over 3 log y plus 1 over 4 log z, and since there is no base, we assume that the logarithm has the same base. So we bring in the multiplication part together and the subtraction part together. So as you can see, we have x raised to power 1 over 2, we take the coefficient of the log to the power as the power of x, minus log y 1 over 3 plus log y log z 1 over 4. So we bring the multiplication parts together. So that's why we have x raised to power 1 over 2, z raised to power 1 over 4, and the subtraction y raised to power 1 over 3. Now of course, x raised to power 1 over 2 is still the same thing as square root, and the other one is 4th root over the cube root of y. So we have the change of base of a logarithm. Now if you have log b to the base of a, log b to the base of a, we introduce a common base for the logarithm. So we decide to choose base c, and that will become log b base c divided by log a base c. Now if you punch your calculator log 16 over log 4, you will still arrive at 2, or you use the normal usual way of by saying 4 raised to power 2, which is 16, is still the same answer for this logarithm. So this is how we do change of base in logarithm.